I really can't do the videos like I used to do and showing and show and tell, so to speak, because I don't have a shop, as I mentioned so many times. And I not only don't have a shop, I don't have any of the test equipment, any of the books or anything. But what I do have is some schematics and stuff on the computer, so I can use that as kind of a Rube Goldberg way of showing something. But anyways, there are a couple of things that I would like to explain to those of you who may have old stereos or record players and so forth, and you may want to know how to increase the bass response of a stereo. Then I want to briefly touch on humming. You know, you get something that hums. Well, you know, on an old piece of equipment, you're going to have electrolytics that are dried out, and sometimes they even become shorted or very badly leaky and could burn out your power transformer if there is one, or definitely can cause problems in the set. So you want to make sure that you always, on these vintage equipments, things that are 40, 50, 60 years old or even more, you need to change the electrolytics. There's no two ways about it. You just don't take and plug something in without at least changing the electrolytics. And of course, things like making sure that the rectifier tube or B plus output of your rectifier tube or diode or whatever is unhooked before you fire it up, because you could damage the transformer. On an all-American 5, of course, there is no transformer, but nevertheless, you got the typical electrolytics that go bad, and like everything else, wax capacitors and things, these are things that have to be changed. So I want to go over some of this stuff with you on little video clips, and hopefully some of you guys out there may you know, get some pointers from it. But again, I want to make mention that I do not have a shop. I cannot be doing this very often because I have no material. There's nothing better than to actually show you how something works and everything. And if I had my shop, I could do a lot more. So this hopefully will help some of you who may be not familiar with old electronics. Thank you. Here is a typical audio amplifier, low power output, using the 50L6 output tubes. But to increase the bass response, you have to change these capacitors, these coupling capacitors, which come off of your phase inverter or your stage. In this case, it's a phase inverter because you're using push-pull here. So your signals are coming off the two plates of your 12SC7, but they're going through a 0.006, if I recall, and we'll go down to the schematic here and look at the parts list. As you can see, C1 and C2 are only of 006. Way inefficient for passing the bass frequencies. As you can see, here is C1 and C2. C2 comes off of this plate, C1 comes off of this plate, goes to the grid, C2 goes to the grid of the other tube in the push-pull circuit. What I usually do is increase these caps to either a 0.05 or an 0.047 is a standard value, or I've actually have been known to go up to a 0.1. That will pass the bass frequencies much better. And if you was to put an audio generator in it and feed 60 cycles before and after comparison using these capacitors and then switching up to the 0.047 or the 0.1, you're going to notice a substantial increase in bass response. Of course, you are limited by the output transformer's saturation because they have small cores, and so you're trying to pass too much bass, it's going to become saturated. So in that case, you will have distortion. Another thing I have done too is on your cathode bypass, which is here. Here's your cathodes. I usually increase this capacitor up to about 100, anywhere from 100 to, I would say, 150 microfarads. Most of the time these are only like 25 microfarads and sometimes even less. Let's look in the parts list and see what this one shows. Just as I suspected, C3 is a 25 microfarad electrolytic, of course. The positive of the electrolytic is always facing the cathode, and the negative goes to the chassis or your common ground. I increased that capacity to at least 100 microfarads. There is a certain point at which it doesn't make any difference, and it stabilizes the cathode voltage and it gives you a better base response. And then you got the other issue of the cathode resistor. You should not have to change that, but let's just see what the value is. The cathode resistor is R8 in this case, so let's go see what value this is. Well, R8 is only a 70 ohm resistor. I'm so used to seeing 120 to 150 ohms in the cathode circuit, but there again, this is a 50L6. It may be some difference there, but anyways, usually you'll find a 1 watt to as much as a 5 watt resistor in that place. Being that this is not a very powerful circuit, very low audio output, 1 watt is sufficient. I'll usually increase these resistors wattage-wise to a 2 watt-er anyhow in this case, just so that they'll run cooler. Now this is in my earlier days when I used to increase the bass response of a lot of little radios and stereos and so forth. Here is a better quality amplifier using a 6L6, no bypass capacitor on the plate. Plate goes directly to the audio output transformer. A lot of times they'll have a capacitor here to ground to suppress some of the high frequency possible oscillations or spikes that may appear. But too much capacity here to ground, you'll lose the high frequencies. Sometimes they'll put a capacitor right across the primary. This is a single-ended audio amplifier, of course, right across the primary. And what that'll do is also reduce the highs. So you got to be careful with putting anything in there. Now, over here is C9 is the coupling capacitor from your audio, your 6J7, in this case, capacity. We'll look that up on the chart and see what value they call for. I usually increase these capacitors capacities to as much as a 0.1 microfarad, but it depends on the grid bypass resistor. Generally speaking, these are around 470,000 ohms. If it's 470,000 ohms or less, putting a 0.1 in this place here would be just fine. If you have too high a resistance in here and you have too much capacity here, the capacitor will not discharge properly and you will get distortion. What you want to do is to pass as much bass from this stage here, from the audio stage to your final output stage, as much as you can within reason, and again, as I mentioned, limited only by the audio output transformer. Years ago, I used to use big-ass audio output transformers, used to get them at Olson Electronics and various other places, oversized audio output transformers, which don't saturate and will give you a tremendous amount of bass. In here, of course, coming in here, there's much smaller capacitors, but their resistances are higher. But being the volume control is usually in the 1 mega or so range. So this, for instance, this could be a 0.001. It wouldn't affect it, so you'd leave that alone, and your bass increase. You do a big substantial improvement by increasing this capacity, and the cathode bypass is to be increased. So let's just see what this value is here, and this is C9. Let's see what they say, and also R16, and see what that value is. I wish they'd mark them on the schematic. It's a lot easier. That's the way I usually do, is mark them right there. Okay, so let's go and see C9 and R16. Here's R16, 330,000 ohms. So it's a half watt rating, of course. So putting a coupling capacitor of 0.1 in place of this 0.5, which is C9, is perfect. And I go to, in a transformer operated set, I increase the voltage rating. I get a capacitor that's, the new ones are like 630 volts. So I would change that to a 630 volt capacitor. But up the value, 0.5 is nothing to sneeze at. It'll pass base pretty good, but you go to a 0.1, you will notice a big difference. Now let's go check the cathode bypass capacitor. Again, we're looking at the 6L6 here. All right. Cathode bypass is C10. So let's look up C10 and see what we've got there. And while we're at it, we'll look up R17 rather, which is the cathode resistor. So we can look up C10 and R17 and see what they put for values in there. Well, C10 is only a 20 microfarad electrolytic. So we can boost that. 25 volts is okay because you very rarely have more than 25 volts. But you can put a 50 volt rated capacitor in there and you'll be fine. But I would increase this value to at least 100 microfarads. So let's see what the resistor R17 is. Okay, R17 is 220 ohms, and that's in the ballpark too. But that's going to have more voltage drop across that than the other circuit that I showed you, and that's up to 2 watts. So that's fine. Cathode bypass capacitor on your audio output tube. So it says 25 volts. I would up it to 50 volts. That gives you a better leeway. Because the more current you draw into this tube, the voltage is going to increase here, and it's going to be higher here. Again, as I had told you on the other circuit, plus is always towards the cathode end. The minus is on your chassis or common negative, whatever the case may be. Let me very quickly touch base on one other thing before we finish out here. This is your basic, in this case, 5U4 is using a full wave low voltage power supply, full wave rectifier. It's a directly heated cathode, of course, so one side is going to be, this is going to be your 5 volts goes across here to light the filament, of course, off of your transformer tap here. Here's your high voltage winding right here, and of course naturally you pick up your B plus here, and here is your main filter capacitors, which are electrolytics. Anytime you get a hum in the radio, when the volume is all the way down and you still hear a hum, you shouldn't, on a tube radio, you should only hear a very faint hum. You should not hear, because most likely your filter capacitors have dried out, electrolytics. So what you want to do is to replace them. This type of circuit here is a voltage divider, where they'll get the main B plus, the highest value right here, and then if they need to step it down a little bit, they tap off of this union of these two joints of these resistors here. And then of course the common negative is down here. It's not marked, but this is the plus side and this is the minus side. So when you replace electrolytics, make very, very sure of two things: polarity and voltage ratings. If you hook an electrolytic up backwards, you'll find out soon enough.